Hello, my name is Maverick Collins. This is my video submission for the Diophantine equation. Don't know how to pronounce that, but the relatively prime greatest common denominator script. And without further ado, let's just get right into it. So we were tasked with building a script that checked if two integers are relatively prime. And then putting those numbers in an equation of a form of ax plus by equals 1, if and only if a and b are relatively prime. For example, if a equals 8, b equals 21, then the equation should be 8x plus 21y equals 1. And then if they aren't, then the output is supposed to be a and b, and then the greatest common denominator of those two variables. So I'll quickly run over my methods. So I have a really basic greatest common denominator function here. Source that from Stack Overflow. This seems to be the standard for this is unique to Python, this way of using intermediate variables. I had to look into that a little bit. Something new I didn't learn, but this is the gold standard for GCD functions or methods. Similarly, this is just checking to see if the GCD is relatively prime. So we're just going to say, hey, does the GCD, is it 1? If it's not 1, then it's going to be true. They're going to, excuse me, if they're a little late over here. Excuse me. I just noticed a quick error. I renamed this. It was coprime because I sourced it and used it. So yeah, if they are relatively prime, then it's going to be true, which is 1. And if they're not, it's going to be false. So for example, 14 and 28 is the greatest common denominator is going to be 14. So that's not going to equal 1. So it's going to return false. Similarly, for 14 and 15, the greatest common denominator is going to be 1. Thus, they're relatively prime. Okay, so this is where we get into the actual equation for that I kind of used Frankenstein of both of these, and then also from this guy on Stack Overflow. So I called it is Diophantine. And so I had to create two dummy variables to store the input values A and B. And then we're going to use this code from GCD where it's finding the common denominator. So while M is true, we're going to then go into this if else. So if the absolute value of n equals 1, we want it to return the relatively prime. Okay, well, yes, this is going to be the output. I have the print statement down here. So if the relatively prime, if the greatest common denominator is 1, we want it to return these values, which I will get into down below my print statement. This is my format print right here. Then if it's not, if they're not relatively prime, then we're going to print out just the greatest common denominator, whatever it is. Like, for example, this was 1428. It's going to spit out 14. So here's our test cases that these work. I'm not going to go through and show it just for time's sake. And the last thing we were tasked with was building a set of 20 different cases where we're creating 20 different numbers we're comparing for N and M or A and B. And then we're testing to see if they're relatively prime or they're not. So my function here is it's going to output if they are relatively prime, right? It's going to call this function is Diophantine, and it's going to spit out AB. And I just, there was no given output, so I made up my own output based off what the parameters were. You wanted AX plus BY equals 1, which I have here. The 1's right there. And it's going to call it, and it's going to return that value. And then if it's not relatively prime, go figure, then it's going to use this return value, where it's actually just using the greatest common denominator. I could have refactored it to get it to use. I mean, maybe you only have two functions. You still need a GCD function. You probably could get away with just one, but I liked for my own clarity, just being able to explicitly state, okay, this one's for greatest common denominator. This one's checking to see if they're relatively prime. And then we're going to put it all together in this one, and we're going to call it in this loop. So I just thought it worked a little bit more seamless, a little easier for my brain to understand, because this was a really foreign concept to me going into this assignment. Without further ado, let's run it. Boom. So there we go. So I could run it. I'll run it a couple more times after I go over this. But so it gave us a random number from 1 to 99. So this first test case is 5438 for A, 1112 for B, and they are not relatively prime because they have a greatest common denominator of 2. And so on for this case, they have a greatest common denominator of 3. 57, look at that. That's, you don't see that. That's a pretty big one every day. That's pretty cool. So anyway, and then with it working, where they are relatively prime, you could see, hey, the greatest common denominator is 1. So we're going to print this equation that Professor Nassar wanted us to print. I thought it would be nice, easier on the eyes to have it print out the actual relatively prime or not relatively prime on the left-hand side, and then systematically go through your A's and B's just to help parse through the data when you're looking at it. But I fulfilled all of the parameters, as you could see here. We'll run it again just to make sure they are random, and it's coming up, you know, when you get a low number like 46 or a 2-digit uh, integer, it's going to throw off the formatting. Yeah, I wasn't too concerned about it because most of the time they're going to be 3 or 4 digits. You run it a couple times, you know, 3 or 4 digits, it's printing. This is just a note for me to upload. But that was it. Pretty interesting learning about this concept. I enjoyed the assignment. It was pretty intuitive after you got the hang of the different functions, and I thought it was pretty fun. So thank you for your time. See you next time.